here we go. We're beginning organic chemistry, and we also call this the nomenclature unit because we're learning nomenclature is just a classifying or naming system. And so we're going to learn how to name and write the formulas for organic compounds. So there's a lot of information that's mentioned here. I'm not going to read through this. You guys can look through this and be able to answer some questions in a multiple choice form probably. So just some stuff about carbon. We talked a little bit about carbon yesterday, and here is some more information for you. So now we're going to jump right into how we go through naming these guys. And the first thing we want to see is that these are called hydrocarbons, and just like it sounds, that means you're going to have some hydrogen and you're going to have some carbon in there, and which we have mentioned right here. We already said yesterday that each carbon forms 4 bonds, and each hydrogen, of course, can only have 1 bond. That's all it can hold, is just those 2 electrons. So we're going to break this up, and you've got this big packet in front of you. We're going to break it up into alkanes, alkenes, and alkynes. So if you think about how the vowel sounds go, A-E-I, it's the same thing. Anes, enes, ines. Alkanes are going to be single bonds. So you'll notice that as we go through, and then what you're going to end up seeing is alkenes or double, alkynes or triple bonds. But we also refer to these as saturated hydrocarbons, and again, that's because it has only single bonds as well. There is a general formula that's written here, and it might be hard to see, but it's always going to be some value of carbons and hydrogens. So if carbon is N, then your hydrogen is going to be equal to 2N plus 2 is what we've got. So you should understand that formula. And then the other thing you've got to know is just all of the prefixes. And these are pretty easy. The first few are maybe a little bit new to you. You might not have learned these before. But number 1 is a meth prefix. Number 2, and this is going to be based on the number of carbons. So let me just write that there. Number of carbons. If there is 1 carbon, then it's going to have a meth prefix. 2 carbons is eth. 3 is prop. 4 is bute. And then after that, it's things that you probably already know, but we're going to write them down again. 5, 6, 7, 8, 9, and 10. So for 5, it's going to be pent. 6 is hex. 7 is hept, H-E-P-T. 8, oct. 9 is known. And 10 is dec, D-E-C. So that's part of the key here, is that you've got to memorize those prefixes. And those prefixes work with alkanes, alkenes, or alkynes. And just notice the big difference. This is what you're going to see. You're looking at that ending. If it's an ane ending, A-N-E, then it's an alkane. If it's an E-N-E, it's going to be an alkene, and if it's a Y-N-E, it's an alkyne. So that's the big difference that we have there. And that's what this tells us right here. It's telling us our number of carbon atoms, and then it's going to end with ane. So in our first example, it says it's usually represented by a structural formula or a condensed structural formula. So in this example, you can see we've got a structural formula and we've got a condensed structural formula. Those are exactly the same things. We're seeing the same thing. What if I wanted you guys to write the molecular formula? Think about how you would write that. Just count things up. What's your first? Good. So C3H what? 8. So that's what we're looking at. The molecular formula, you guys saw that. You answered some questions on that with your homeworks. If you saw C3H8, you drew this. In fact, this is one that was either in an example or your homework last night. And this is what it would look like, this structural formula. Here is a condensed structural formula. And the reason it's written like that is because it's showing how the hydrogens come off of each of those carbons. So that's just another way of writing that. Okay, so now we can talk about something known as structural isomers. If you have an isomer, then it means it has the same molecular formula. Let's just write that. Same molecular formula. But in this case, because it's a structural isomer, we're going to see a couple different types of isomers also. In this case, what's different is it has a different structural formula. So isomers always have the same molecular formula, but something else might be different. So in this case, a structural isomer, it's a different structural formula. So again, I could go through here and say carbon. There's 1, 2, 3, 4, 5 of them, so that's C5. And then in this case, I've got 12 hydrogens. So if I looked here, I would have exactly the same molecular formula, C5H12. So because they have different structural formulas, there's actually a different name for them, and that's what we're going to learn today is how to go about naming these guys. So an atom or a group of atoms may take the place of a hydrogen in a hydrocarbon. So that's what we're going to end up seeing here, is that those guys are considered an alkyl group. You can also hear them termed substituents or a radical, but most often I'll call them alkyl groups. And alkyl groups, it's just going to be similar to an alkane, but one of those hydrogens has been removed, and it just attaches, it takes place of the hydrogen within a compound. So the way that they're named is they're named by removing the ane ending, so you get rid of that, and you add a YL, an ill ending, so that's where that alkyl group comes from. And you're just commonly just going to have up to a few carbons. So you might have a methyl, ethyl, propyl. You can have more than that, but those are going to be your more common ones. And they're not named by the total number of carbons, which that's according to a set of rules there. So the way we're going to name these, whenever you're trying to name an alkane, so we're back to alkanes now. This was just mentioning that there is a little alkyl group that we're going to have to worry about when we name these things. You always find, and this is huge, and this is going to be for alkanes, alkenes, alkynes, you always find your longest continuous chain of carbons. It's got to be a continuous chain. If you were to put your finger on that chain and not pick it up, you would hit every one. And you're going to then number your carbons in the chain starting at the end that will result in the smallest number for the position of the side chains. And those side chains would be examples like your alkyl groups. It could be some other things as well, which we'll see here shortly, but that's going to be one of the main things. It's okay if this doesn't really make sense yet, but just think about this. We're going to have to think about our numbering. We're going to find our longest continuous chain of carbons, and we have to consider the numbering of it. We're going to want it to be smaller numbers, not bigger numbers. So in this first example, again, we see, actually this looks like it's C6H14 in both of these cases. So the first thing I need to do, I count my carbons. Can I make a long chain of carbons? And the answer is yes, we can. And if I were to start numbering from here, like that, I would see that my alkyl group, which is right here, notice how that wasn't part of my long chain? That alkyl group comes off of number 4, so that's not correct because I could start numbering it from this side and have it come off of number 2. So that would be the correct way to do it. So that's what that second little blurb was saying, is always have that number system where it's that shortest, the lowest number that has your alkyl group, any of those side groups that come off of it. Let me just also show you another thing. Here, I'll do it from this one. If you wanted to say, hey, here's my longest chain, hold on. I need to actually touch the yellow. There we go. If I wanted to say, here is my longest chain, my finger never came off of there. So yeah, that's an acceptable long chain of carbons also. But again, notice that your carbon, your alkyl group comes off of that second carbon. So it gives you exactly the same answer. But if you like choosing that as your long chain, that's perfectly acceptable. So just kind of get used to that idea of thinking outside of just straight lines. Okay, so when we name this, we're going to name the alkyl group giving the position number followed by the name of the alkane longest chain. So the way I would do this is I would say, okay, my longest chain is going to be 5. So for 5, let me see where I can write this. For 5, I know my prefix is pent. And lots of times I won't start at the very beginning. I'll give the root name for the substance, and then I can attach my alkyl groups to the front of it. So I have 5 carbons, and it doesn't really matter if you choose this one or that straight one. So I have 5 carbons. Everything's single bonded, so I know it's going to be an ane. There's a pentane. But on top of that, I've also got this alkyl group right here, CH3. And think about which alkyl group this is. There's only one carbon, so what would you call that? Any thoughts? It's methyl, and it's coming off of number 2. So we're going to call it, it's a 2-methyl pentane. So we will get to our dashes and comma rules here in just a second. But in fact, it tells us 2-methyl pentane. When more than one side chain exists, so sometimes you'll have more than one alkyl group. And what you have to do there is you have to possibly use prefixes if your alkyl groups are going to be the same. If you've got 2 methyls or 2 ethyls or 2 propyls or 3 of those or something, you're going to have to use some prefixes. The prefixes that you would use are these: di, tri, tetra. So those prefixes tell you those are used for alkyl groups. If you've got more than one of those alkyl groups. So for example, let's just do this right here. We've got our carbons, 1, 2, 3, 4, 5, 6, 7, 8. Notice that had I numbered it in the opposite direction, my first alkyl group would still be coming off of number 2. But this is the correct way, the way it's numbered, because my second alkyl group, if I numbered it differently, it would be coming off of 1, 2, 3, 4, 5. It'd be coming off of 5. So instead of having a 2, 4, 7, we would have a 2, 5, 7. So those are larger numbers. You've got one number that's larger. So the way that it is numbered right now is the correct way. You don't want to do it the other way. But what you also notice now, okay, so we've got 8. So we know it's going to be an oct. It's all single bonds, so it's going to be an octane. You've got an alkyl group. All of these are methyls. And you then just have to say your numbers. So this is going to be very sloppy writing, but it's going to be a 2, 4, 7. Notice we separated those with commas. Then you come in between your numbers and your words, letters. You're going to put a dash in there. So it's a 2, 4, 7. And then we have to think there's 3 of them, so it becomes a trimethyl octane. 2, 4, 7 trimethyl octane. Okay. That's what chemists do. They sit around and they think of how to name all of these complicated names. But actually the reason it's important is because these things have different properties. So even though you might have the same number of carbons, if you've got these different alkyl groups, they have very different properties. So it's important that all the chemists can communicate and talk about make sure everybody's on the same page and they know what they're talking about. Okay, so now if different side chains exist, then you're going to list the groups in alphabetical order. Yeah. Okay, so we're going to list these in alphabetical order. And in this case, again, you always start with the idea that you are going to do your longest chain of carbons, continuous chain of carbons. And maybe don't follow, this is numbered correctly, but maybe you would say, ooh, let's see about this guy. 1, 2, 3, 4, 5. Nope, that's not it. So it ends up being not that. I have to be careful with this. Hold on. Okay, so it ends up being that you can get 6 carbons there. There's your longest chain of carbon. And because of that, we know it's going to be a hex. Well, we're just talking about alkanes, but double check. Everything's a single bond, so it's a hexane. Then I see I've got this guy right here, and I've got this guy right here. Notice that those are different. What would you call this one? Methyl. Because it's one carbon. What would you call this one? Ethyl. Ethyl and ethyl. Great couple there. So in this case, what we just read up above is that you have to put it in alphabetical order. So ethyl comes before methyl, and then you have to go back and you have to think about your numbering. Where is the ethyl, which is going to come first? Well, that comes off of number 3. So it's going to be a 3-ethyl dash 2-methyl. And if you space it perfectly, it just becomes part of that same word. So there is a dash here. 3-ethyl dash 2-methyl hexane is how you would name that one. Okay. Now, on this next one, let's see if we can move some stuff here. On this next one, this is just what we were talking about. You separate numbers from numbers with commas and numbers from words with hyphens. And then this is just some other information for you. What you end up seeing is that the mass of these compounds, as you get more and more carbons in there, is that increases, so does the boiling point. So they're going to exist as liquids for a longer time. It's going to take a higher temperature to get them to turn to a gas. Okay, and then the other thing is that because these substances are non-polar for the most part, they do not have poles. They're going to be symmetrical, and we'll talk more about that as we move on. But they're non-polar. That means that like dissolves like, and so they would dissolve in non-polar substances, and therefore they would be insoluble in polar substances like water. Okay, so now we have just finished talking about alkanes. Now we want to think about alkenes, and with alkenes, same exact stuff that we talked about earlier, but instead of having a single bond, you see that E there, so you really just have to be observant. You see that E there, that means that it's going to have a double bond. That's it, just a double bond. And so you have to think about where that double bond is. And here, double covalent bond, and it's considered unsaturated because now it's not all single bonds. And it's going to end in ene. So instead of having that CnH2n plus 2, it's going to be CnH2n is your formula. And the same naming system, you still have to think about your prefixes, but notice, and I hate how these numbers are here, I think that was the auto formatting, but this is still for 2 carbons, 3 carbons, 4, 5. Notice that there is no 1, and that makes sense. Talking about double bonds. Can you have a double bond if you only have 1 carbon? Not possible. So there is no such thing as a methene. Not possible to have a methene because you have to have a double bond. So the simplest one we can start with is an ethene, is how we would do that. Okay, so again, our rules are to figure out our longest chain, and that longest chain must contain the double bond. You can't have a double bond as part of an alkyl group. The double bond has to be part of your longest chain. And again, you're thinking about your lowest position number, but your lowest position number now has to be associated with the double bond. Okay, and going back to our double bond, that takes precedence over anything else. So any of those substituent groups, those alkyl groups that we talked about, it is going to take precedence. So in numbering, we would say this would be incorrect because 1, 2, 3 is where my first double bond, or the only double bond, comes about. Here I can get it at 1, 2. So this one right here is the correct one, not this one. And in this case, we would say 1, 2, 3, 4, 5, so that's going to be pent. But there's a double bond right there, so it's not a pentane, it's a pentene. Sounds like shampoo. And we also notice we haven't taken into account all of the carbons. We have to consider this one also. But remember, we have to think about our numbering system with that double bond. So even if we didn't have this alkyl group right here, the CH3, it would be a 2-pentene because you have to number, you have to name where that double bond is. So it's a 2-pentene, But on top of that, we've got the alkyl group of methyl coming off of carbon number 4. So it becomes a 4-methyl 2-pentene. Okay, so next example, we look for our longest chain of carbons. Notice that you've got your double bond right there. That has to be part of your longest chain. Even if you can make a longer chain without that guy, you have to make your long chain with that double bond because it's the only way to do it. That has to be part of your ene, your alkene. So here, this is going to be where you're going to want to start numbering number 1 because you want your double bond to be the lowest number possible. So 1, 2, 3, 4, 5, 6, 7. That's your lowest number. So we know that that's going to make it a hep, and it's a double bond, so it's a heptene. Where is that double bond? It's on number 1, so it's a 1-heptene. And then we look and we see what else we've got. Looks like we've got this big guy, 3 carbons. So what's that alkyl group going to be called? It's propyl. So we've got a propyl, and it's coming off of carbon number 3. So you get a 3-propyl 1-heptene. These are kind of fun. Put away the crossword puzzles and Sudokus and stuff. These are more fun. So that would be our name on that guy. Okay, another isomer. Remember we said that for an isomer, it just means it has the same molecular formula. I'm just going to repeat that. Same molecular, that's what that says. Can't write this side. Same molecular formula. However, for a positional isomer, it has a different place where the double bond is. If we compare these two, we're saying these two are isomers of one another because the molecular formula is the same, but instead the position of that double bond is different. So it's a positional isomer that we see. If you wanted to say what your molecular formula was, C4, and it should be H8 in this case. So they both have that same molecular formula. Double bonds are in different spots. Oh, and that's what we've got right here. Okay, so because the carbons cannot rotate about a double bond, they can also form something known as geometric isomers. So again, same molecular formula, but instead we're talking about the geometry is going to be different. These are probably the toughest, but don't let them be. There's 2 different types. You can have a trans and you can have a cis. Trans and cis. So again, the reason being, they can't rotate on that double bond. So you have to think about which side of that double bond they're actually on. So in this first example, let's just go through and write our molecular formula. 1, 2, 3, 4, 5. So you've got C5, and then 3, 4, 5, 6, 7, 8, 9, 10. Okay, just wanted to check. So in both cases, you have that as your molecular formula. But in naming this first one here, we're going to say our carbon, since there's 5 of them, it's going to be a pentene. We have our carbon, our second carbon, is where we first see our double bond. Notice we put it on the second, not the third. I'm going to start numbering from here, and it's the second, not the third. So you get a 2-pentene. Okay, so we see, if I were to draw a line separating that double bond there, here I'll do it for both of these guys. So think of that as a line. We've got this carbon group here and these guys here on separate sides of that double bond. Since they're on opposite sides, trans tells us that they're on opposite sides. So we're going to call this a trans 2-pentene. Whereas in this case, here's our double bond. We've got these guys on the same side of that double bond, so this is going to be a cis 2-pentene. a minute. Okay, so now we are just about done with this. The last one we want to look at is alkynes. And with alkynes, notice the ending, it's a triple bond, just one triple bond. Again, this is going to be an unsaturated hydrocarbon. Here's our general formula is CnH2n minus 2, ends in -ine, and again, you can't have a methine, but you can have an ethyne. We did that example yesterday for homework, I believe, or maybe it was in our notes. So these would be some examples that you've got there, nothing really that new. And last little thing I want to mention is that do not put things into rings unless you're told somehow that they need to be in rings. So there is something known as cyclic hydrocarbons or cyclohydrocarbons. And here they're formed together in a ring. It can be with anes, enes, or ines. And when you do this, in naming them, you have to name them with cyclo. And here, 3 carbons, so it's cyclopropane. 3 carbons that are all single bonded, so it's just a cyclopropane. Here, cyclobutane, cyclopentane, cyclohexane. So those are all single bonds. And if you have some, you know what, I think we get to these. I'm going to not even mention much about these other than say there's these other types where you can get some double bonds in there. They have to alternate because it's not possible for them to have double bonds on every single carbon. It's just too much. So we get to this on another unit when we'll spend more time with that. So just be aware of those, but we won't hold you responsible for too many of those. Okay, now's the big part where we have to go through and do our examples. I'm going to do this in another video.